But the fact is, see, it is the way this design class is going to work. Today I'm doing it because some students may not have joined, but I should not be doing recording, because during the design class it will run for 3 hours, and it is expected that it would be continuous interaction. So if we record for 3 hours, I mean, what will you do with the recording anyway? There will be a test definitely at the end of the after you complete your these modules. For that, you need to go through the recording. Uh, I am not sure. I think you have to, more importantly, you have to refer the material that you generate. That means you have to do some calculation and you have to post it. You have to scan those documents and post it. And so you have to. Those are basically the material that you have to refer, and the book before you take the exam at the end. But I am doing the recording as you said, but probably I will not continue this for some time. I mean, maybe for some time, since today not all students are present at this time, but it will not be from next class definitely. This recording is not required. So you can have this, as I was mentioning, that it could be British standard, it could be ASME, American Society of Mechanical Engineers, or it could be Indian standard. Okay, IS. So I was discussing about design of a pipe. Simply, it's a thickness of a pipe. So I have already come up with a diameter of a pipe. How I decided on the diameter? I have a flow rate. I know what is the velocity, what would be the frictional pressure drop, what kind of if there are bends and other things, then how that would work out, what kind of pressure drop I have, and based on that, I came up with some optimum diameter for that pipe. So now I want to know what is the thickness of that pipe. So what should be wall thickness such that the internal pressure that I'm putting this subjecting this pipe to, that internal pressure should not rupture the pipe. So for that we have to measure the hoop, we have to calculate the hoop stress, we have to see it is a typical strength of material as we have studied in mechanics. So we have to go through that kind of analysis. But what you will find here is that when it comes to these codes, I mean, when you design the pipe, you have to refer to some code, because at the end there would be a stamp that, okay, this pipe is designed as per British standard so and so, or IS code so and so, that is Indian standard so and so. So that stamp has to be given. And that stamp you can give only if you follow the procedure that is given in the BS code or IS code or ASME, or different countries, they have their own codes. Now, why they are different? If finally you are calculating the hoop stress, if you're finally calculating what is when the rupture takes place, so it comes from first principle. So why are we bothered with this? Because there is a lot of experience that has gone into this when these codes are written. So it is there is a volume of experience available while while fabricating these vessels and working with those other components. So that experience has gone into the design. I can give you some. I mean, very maybe in simple terms, I can say something like this. Suppose your thickness, as per theoretical calculation, comes to 2.55679 millimeter. Okay. So first of all, if you go to the market and try to purchase this kind of a thickness, I mean, as if you have to make a pipe by getting a plate of this thickness and then roll it and then weld it. Okay. So when it comes to getting a plate of this thickness, you'll find that nobody makes that kind of a plate. Plate is either available in some there are certain fixed thicknesses at which the plates are available. And if you look at this book, in this book there is at the end there is a table given where these if you look at, let if you look at these, 1 second. If you look at these appendix B, if you look at this appendix B, in the bottom half of this page, appendix B, you'll see different thicknesses are given for steel plate. Okay, so these thicknesses are the thicknesses at which, I mean, these are available thicknesses. So then immediately your concern would be that, okay, the thickness that I have converged to, that thickness is first of all not available. So then you have to do the design, not, I mean, you do not calculate the thickness of the pipe. Rather, you accept the thickness of the pipe, some thickness of the pipe, and check whether it will rupture at that pressure or not. So there is a paradigm shift. I mean, the way the calculation is made. Then there could be some simple, I mean, very small things are there which one only gets to that through experience. It is something like this, that if you have a pressure vessel, let us say, suppose this pipe, suppose I have a pipe here, suppose this is the pipe, and this pipe is connected to a vessel. This pipe is connected to a vessel like this. And then this vessel has some outlet, some valve, and this valve is closed and all this. Okay. Generally, whenever you have such a vessel, there would be a safety valve. Why the safety valve is there? Because if for some reason the pump, there is some failure and their fluid is being pumped continuously to the vessel, and outlet and everything is closed, then there would be a rupture in this pressure vessel, because every vessel is designed against some design pressure. So when there is a rupture in this vessel, so everything will spill out, and that would be catastrophic. So instead of that, you want to have a safety valve here, and safety valve is set for some operating pressure, with the understanding that if ever the pressure in this vessel exceeds some value, then the safety valve will pop up and fluid will be released, so that there will not be a catastrophic failure. There will be shreds of metals flowing around or flying around. That should not happen. So this safety valve will pop up at a pressure, let us say 100 atmosphere. So you have made an arrangement that my pressure vessel can take up to 100 atmosphere. So I put a safety valve which will pop up at 100 atmosphere. Now, fact is, when you are doing this design of this pipe or this vessel for that matter, if you do the design also based on 100 atmosphere, then you can see that there, suppose pressure is increasing, right? So if somebody plots pressure versus time, then they will find that pressure is increasing because of some failure. So pressure is increasing with time. So at this point, it exceeded 100. At this point, it exceeded 100. So the safety valve, there is a spring, so it and a weight given, and the safety valve pops up. So by the time the fluid is released, there is always a lag of second or even 100 milliseconds or so. There is always a lag before between the time the pressure reaches 100 atmosphere and the time the fluid gets a chance to release from this place. So that small lag, even 100 milliseconds, that lag, during that time there would be the pressure is linearly increasing, so pressure will increase beyond 100. So if you work with 100, it will not work. So immediately there is if you look at IS code, they said, okay, if the operating pressure is specified at 100 atmosphere, you take 5% extra and consider that to be the design pressure. Okay. So these are, I mean, where did, now if you ask me, where did you come with this 5%? Okay, what is the theoretical basis for it? I don't have an answer. These are empirical. Empirical means these 5% people have arrived at from their experience. They designed it with 100 atmosphere. They found that it failed. Then this, then they found that if we keep a 5% margin, this thing is going to work out fine. And based on this experience, these codes were written. IS code also takes into account this same thing. So IS code has so India has produced its first code, as you can see in the screen, unfired pressure vessel IS 2825 1969. So so there are these IS codes, and they have laid down the procedure that okay, you find the design value, then you do this, then you do that, things like that. For example, you will find that you are working with a pressure vessel. Suppose I work with, so there would be, this is called head of the vessel. So how do you make a head? You take a circular plate, you take a circular plate, and then you try to bend it, bend it peripherally. So around this location, you try to bend it so that it can it can form a head. I mean, you think of it, because finally you have to weld it. Finally, you have to weld it to the straight portion. So moment you bend it, you compromise on this thickness part. So you have to provide some extra. How much extra? So these margins, these things are discussed in the IS code. These things are so when you do this design, you have to you have to take into account, because then only you can say that this design is done as per IS code so and so, and then that industry will accept it. Okay, otherwise just doing by doing working with the first principle, that may not be, that is not sufficient. Okay, so these in this course, what we are going to do is we are going to do, so this is more of a mechanical design we are talking about, mechanical design of fluid flow equipment, fluid flow components. So out of these, we are going to do the mechanical design of, first of all, a pressure vessel. Next is we will do head. Head is something which I mentioned just now. Now there are different types of heads possible. Okay, so there are, you may see 4 to 5 types of heads are possible, and their design has, they have their unique way of designing it. So this is going to be a long exercise. Then we will do number 3 is compensation for opening. Compensation for opening means, suppose I made open this part so that the pipe can go and fluid can go into this pressure vessel. So I made a opening here. So I have made a opening here, right? So moment you do a opening, so that means you remove some material. So this material was doing what? This material was supporting, right? As far as this pressure vessel is concerned, these pressure vessel, these material that was present here, which you removed so that you could make a hole so that the pipe can go in, so that material was supporting this pressure vessel. So that material is now gone. So one has to support, one has to put additional layer. You may see there would be an additional layer surrounding it. It is more like a circular pad, you will see. So that has to be provided so that this opening area is compensated. So this compensation, what should be the thickness of this pad, what should be the diameter of this pad, this is something which we will design. Then the fourth component is flanges. Flanges, suppose I have to attach a pipe with with another pipe. Suppose when it comes to a pipe, generally pipes are made in lengths of 6 meter or 20 feet, around that. Okay, so this is a very fixed size. So suppose I need a 10 meter of pipe, I cannot get 10-meter pipe. I have to purchase two pipes, 6-meter and another maybe 4-meter, and then 6-meter. These two pipes, they need to be joined. Now you must have seen in our household, we have, when we have these water connections from ground floor tank to upstairs tank, those pipes, they have various adapters to join two pipes. But when the pipe size is large, and in industrial scale, we generally have a flange. That means one pipe comes here, then I have a flange attached to it. We weld this flange. We weld this flange around this pipe. Okay. And then I have, so this pipe ends here. Another pipe comes there also, there would be a flange, and this flange is welded here. And then in between you put a gasket, an annular ring, just like the ring you have in your pressure cooker. So that kind of a gasket material you place, and then you press them hard, and then there is bolts placed. So it is like I have a circular plate, annular plate here, annular plate there, and in between. So there you will have an annular plate there, and then there are bolts like this, and then the other flange comes there. So that will also be an annular plate, and there also there would be bolts. There would be bolt holes, and these bolts will be passing through this. So bolts will be passing from this flange to other flange, so that two pipes can be joined and in a watertight manner, so that fluid, when you have high internal pressure, fluid will not leak out. So the asbestos or some gasket material that you have. So as you put pressure, as you tighten the bolt, this gasket material, it sort of flows over the nook and cranny of the surface, because surface has certain roughness. So this is a soft, this gasket is a soft material. So the soft material will try to adapt to the surface roughness, and so that creates the sealing effect. Okay, so there are a lot of other considerations. So when we tighten the bolt, what kind of stresses we are subjecting these gasket to, and how many bolts you need. So those kind of details we'll work out in this number 4. And number 5 is we will work with tall vessel. So tall vessel means with these pressure vessel that I mentioned just now, these are typical small vessels like these. This kind of vessels you'll see next to, when you are back to campus, you will see similar vessels next to a swimming pool. Similar vessels you will see in front of Nalanda complex. So these are vessels with some leg type provided. These are called lug supports. So these are vertical vessels like this, but their height is not much, few meters. Okay, but when the height of the vessel exceeds 20 meters, let us say, so those are called tall vessels. And you might have seen these kind of vessels in industry, particularly if you ever drive by uh, any refinery or petrochemical complex. You might have seen those tall towers. So those are basically tall vessels. Now, tall vessels have their own considerations. For example, tall vessels, have you thought of this? That the bottom part of the vessel has to bear the weight of the top part. Okay, so bottom part should be thicker than the top part, because top part's weight is carried by the bottom part. This is not just only consideration. There are other considerations as well, particularly the wind load. Tall vessels will be subjected to much more wind load, and that has to be checked. That has to be verified, whether the wind load is, whether the thickness that you choose for the plate is sufficient, that during a wind or seismic activities, if that breaks. So those are the tall vessels. One has to do that design. And the sixth component would be the support. Any vessel, any vessel will require, support. Support in the sense, this type of vessel would be simply requiring something called a lug support. That means there are, you'll very much see three lugs coming out, and then there would be a bearing plate, And then through this bearing plate, there would be bolts running, and these bolts are grouted. That means here you will have cement. In that, the bolts will be going in. Similarly, here also you will have a bearing plate, and through that there will be bolts which are running, and they are grouted. So this is how you can do it for a moderate size vessel. But suppose I have a horizontal vessel, okay, or suppose I have a tall vessel. What kind of support you need? So this would be the sixth component, the designing of tall vessel support. Basically, the support that we will cover here is the support for tall vessel, because that is something which is basically the short, the small vessels are not that you will not encounter that much. And there are horizontal, you can hold the vessel horizontally also on a saddle support, but saddle support also design is there. It is already in BC Bhattacharya's book, it is tabulated. In tall vessel, in case of tall vessel, there are some more calculations one has to do, because tall vessels will be placed on something called a skirt support. So that design of skirt support will be considered. So these are the modules that will be taken up as part of this course. Okay. Any question? Any question? Someone please say it is, because otherwise I'm not, it's not clear to me whether I'm getting it through. Students?
So we don't have any doubts right
Okay,
now.
so but you could listen whatever I said that day, because that feedback is important. Okay, now this is the way this is the way we will operate. Now let I will what I will I'm going to let me close this section and just talk about it. What I expect you to do is you have to make a notebook. First of all, don't write on scattered pages. Prepare, get a notebook. It is important that you have a notebook, because you will have everything in a consolidated place, and during before the exam you can at least have a, you can go through the notebook and you can go through the steps. It will not be, don't go with a small notebook. Rather go with what kind of notebook I would say. You will have those bigger pages, not A4, slightly bigger than A4, slightly taller, slightly slender than A4. Those kind of notebooks are typically you follow in your while taking notes. So take one of those notebooks. We are going to use, I mean, you can think of at least at least I would say 6 pages per module. So 6 into 6, 36. So roughly at least it should be 50 pages notebook. Okay. So try to have a notebook of at least 50 pages. That would work out fine, I believe. And you have to, what I will do is I will give you the assignment in the beginning of the class. Okay. First, what I will do is I'll give you, I'll tell you briefly what to do. Okay. For example, when it comes to, let us say, head design. So there are 4 or 5 different types of heads. So I will discuss what those 4 and 5 types of heads are, how the design is done. So I will have a brief session, maybe half an hour, 45 minutes. And then the question, I will put the question. So then you have to start solving that. You have to calculate, let us say for head, it would be the thickness of the head. So you have to calculate the thickness of the head for different types of heads. So that calculation, it has a procedure. That procedure has to follow IS code, and the procedure is in a consolidated manner is placed in this book of Introduction to Chemical Equipment Design. So if you have this book in your hand, you can very well refer it, and already example problem is given there. So you have to follow step by step and complete that exercise. So by the end of the class, you have to complete that exercise. That means if there are 5 types of heads we are talking about, so they will have 5 different thicknesses. So you have to put a table showing that these are the 5, and with all the calculations. So that has to be registered, that has to be logged in that notebook, all your calculations. But don't put a lot of rough work. For rough work, you can have another rough page. Put the calculations nicely in that notebook. After that, what you have to do is you have to scan those pages, of the notebook and upload it. We are trying to open a module in Moodle. Let me see how it works out. Otherwise, in MS Teams also, I can give you an assignment where you have to upload those, say 4 pages, 5 pages, whatever calculations you have written on the notebook, and you arrived at those design numbers, design value of those thicknesses. So scan it and upload it. The original notebook remains with you. Next class, when you come next week, you will have that same exercise. You will have a very similar exercise for the next problem. Okay, for example, for compensation. So for compensation, you will have another problem which you have to solve. First, I will have a 45 minutes introduction, half an hour to 45 minutes introduction. After that, you have to solve the problem and scan it and upload it in the site, either Moodle or MS Teams. The assignment will be provided. Okay, so this is how this week by week it will proceed. So once we complete all these 6 modules, then we will have then we are ready for a test. We may not have immediately, we may not have the test. We can wait because we have the entire semester left. Since we are doing everything in one go, so we will have the rest of the semester left. So we have to complete these six modules. Ideally, if half of the class would have done these 6 modules, and midsem would have come, and after midsem, this group of students would have gone to fluid flow lab and completed another 6 or 7 modules of experiments. But that is not happening in this case. So we are just trying to complete these 6 modules. During when you do your own calculations step by step, if you have any questions, definitely we will be there. We will do, myself will be there, and there would be other helping assistants will be there who will answer to the questions you may have. Okay, so that time you can, while working on this problem, probably speaking it out all of you together will not be a good idea. So if you post your question, then that can be adequately answered. So that is how we are going to operate as far as this course is concerned. Is this clear to everybody?
So, sir, the assignment that we have to solve
Hmm.
means the topics for that will be teach on that day only.
First of all, for example, today I will tell you few chapters which you have to read before you come to the next week's class. So by the time you come to the next week's class, I'll tell you that the next week's class would be, let us say, pressure vessel, and maybe one head design, one of the heads out of the many heads, one of the head design and the pressure vessel design. Let us say I do it, or maybe in the next class we can do combined pressure vessel and head design both. It depends. I mean, we will start with if we can complete pressure vessel and head design, that is good. Okay. So we will we will tell you. So I'm telling you right now that in this book you have to read I mean pressure vessel and head design will cover first 4 chapters, I think. Yes, because fourth chapter is head. Yeah. So you have to read first 4 chapters of this book. So when you come to the next class, you have to come prepared with first 4 chapters. And in the next class, our target will be to complete pressure vessel and head design. If it turns out that it is becoming too long and one head design is left, we'll think about it. But our aim would be to complete pressure vessel and head design in the next class, next week's class. And then we have you have to upload all those, and then again when you come back to in the next week I'll tell you that okay, next week in the next week's class will be compensated opening.
Sir, like,
So
where should we be uploading it on Moodle or via mail like we did last time?
via mail I do not want to do. Instead, I think see, so far I have not received the Moodle login. Okay, because I have to get the Moodle login, and then we can set all these access, etc. So I have not received yet. So if we do not receive by the start of next class, in that case I'll simply give you an assignment through Teams.
Okay, sir. Yes.
Okay, and if we get the Moodle access, then it will be Moodle. So you have to upload the scanned copy of your notebook for that day. Okay, and at the end we will have a test that would be most likely through Moodle, and it would be small numerical or multiple choice, depending on there'd be a lot of questions. I mean, not just one question and you have to do, or one design problem. It's not that way. There are a lot of small questions, and one question simply could be what percentage you add to the operating pressure when you design a pressure vessel, and that I mentioned just now, 5%. This could be a question. Okay, so there would be a set of questions at the end. I mean, there would be a test at the end. Okay, so your evaluation would be your day-to-day, I mean week-to-week performance, which you are uploading as scans, and your performance in the test. Any other question? Once we are through, once we know for sure that we have understood how we are going to conduct this class, then there is one student has raised this point that he has some uh, algorithm design, some class,
Sir, like
So
most of
not
the
just
most
not
of the
just one.
students,
How
yes, sir.
many? How
Most of the
many?
students this sem are taking algorithms laboratory.
No, no. Most is not a correct rigorous term.
Sir,
Can
around,
whoever has taken algorithm design, can you raise your hand? Let me see how many people have taken and how many people need this to be moved.
And sir, actually, there's one more thing. Like this slot, like it is also blocking the slots U and H. So there are some courses there also.
But the percentage is much less. I see how many raised hands. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay. Who is no 1, 2, 3, 4, 5, 6, 7, 8, 11, 12, 13, 14, 15, 16. Okay, so you prefer Friday. That's what you're saying, right?
Yes, sir.
Yes, sir.
Okay, we can do it on we can do it on Friday. There is some comment. So that we can use this slot for additional. Fine. So we will. I can do it on Friday. That's fine. I mean, whatever popular demand, whatever it is. So we will hold the class on Friday, not Tuesday. Okay. And so is this? I'm closing the recording now. I think we have discussed all the essentials.